So yeah, oh, there's audio. Good. Welcome everyone. I'll just get started. I needed to have my company logo as the first one just to hide the next one. So I'll get started once the next one is done. So yeah, needed to have a video. Have some fun. Welcome again. My name is Mohn. I'm from Norway. Works for a company called Proact as well, I think my title is Chief Technologist or something like that. Depends on which day it is and what I'm doing, which role I have. But post-sale, pre-sale, design, architect, worked with VMware technologies for almost exclusively for the last 20 years. I'm pretty easy to find. If you Google me, my name, or whatever's here, you'll find me. So get in touch if you want to. Shouldn't be difficult. And my last slide today also has a QR code with a link to everything I've been through in this session. So I'm doing a bunch of commands and stuff like that. There's no need to take pictures of those. Everything's available afterwards anyway. First off, a little apology for the session description. I mentioned that I should be talking about misconfigurations and how they can be utilized by attackers in a vSphere environment. I'm not really going to do that because there are other sessions as well that cover some of the same topics. So in a kind of underhand way, we kind of organized that a little bit. So I talked to the other ones who have similar sessions so we don't cover the same stuff. And these are the sessions I'm talking about. So Austin from Valley Cyber is talking about Scattered Spider and their hypervisor attacks later on today. I actually have a slide about that, but not specifically what they do, but what they should have done, which is kind of fun. Hopefully they don't read my blog post afterwards. But and Anders, who's actually here, has a session about protecting VCF and the hypervisor platform against ransomware attacks as well. So if you want to have a security-filled day, have a look at those as well. They have different content than I have, so that's good. So let's get into it. As far as this session doesn't cover VCF. I'm talking vSphere. I'm talking mostly ESXi, specifically, not vCenter that much, but ESXi. But in any environment where vSphere is running, it's basically the holy grail for any attacker, right? It contains mostly everything you have. Be it your domain controllers, your financial data, your HR data, whatever it might be, it's all located probably on a VMFS data store somewhere, accessible from an ESXi host, which means basically all your data is available from those hosts. And that's kind of the highlight or the kind of topic for today. So if someone gains unauthorized access to vSphere, ESXi or vCenter, basically they have access to everything. So as I said, once someone gets root access to an ESXi host, all bets are off, right? They can pretty much do anything they want. But there are some peculiarities that I'm going through that might not be as obvious as stopping VMs or deleting VMs or copying them or whatever. They can do more fun stuff as well. And mostly that's done through, well, I'll go through that as well. How does someone get root access to an ESXi host? There's a bunch of different ways that can happen. It might be credential leak somewhere. There might be an unpatched vulnerability that's available that someone exposes or exploits to get access. Might be, called it malicious activity. It might be internal malicious activity, right? It might be someone inside the company that does this as well. And there's probably methods that we don't really know about yet either, right? So there are many ways that can happen. But what's the point? What are you actually on about? And well, it's about running code on ESXi hosts. This is one of the things I know Anders is going to talk about, but we have this advanced setting called VM kernel boot exec installed only, which is supposed to prevent unauthorized, unsigned code from running on an ESXi host, which is good. Problem is, someone has root, they can just turn it off, so it doesn't matter. Even if it's on by default, which it is in vSphere 9 or VCF 9, you can just turn it off if you have root access, so what's the point? The other thing is, we have what we call living off the land, which is basically using native tools to do things they weren't perhaps designed to do, or in a way they weren't designed to work, which is what I'm going to go through a bit of today. So-called lol bins, living off the land binaries, as I said, using native tools to do fun or unintended things. And that's fun in brackets. I guess the definition of fun is whatever you want it to be in a way. It's not fun for you as an administrator. It might be fun for the attacker, right? OK, so I have some demos. These are pre-recorded, mostly because one of them took 1.5 hours to complete. That would have been a pretty boring session. I cut that down to 2 minutes. So yeah. The first set of demos is what I call rogue or ghost VMs. These are some peculiar VMs that I'm going to show how work and how you can utilize them. And also go through how you might exfiltrate data from other VMs in the environment. And lastly, how you can actually encrypt VMs on a data store using native built-in ESXi tools without the need for external code at all. So first off, the ghost or the rogue VMs. These are called that because the MITRE, the guys behind the MITRE framework, their environment, their demo environment, lab environment, was actually compromised by someone doing this. And they called it rogue VMs. And CrowdStrike created a script to find these. They called it ghost VMs. So pick a name. I pick both, basically. So what are they? What is a rogue or a ghost VM? Well, it's a VM that runs on an ESXi host, but it's not registered with either vCenter or the ESXi host itself. So it's running. It's utilizing compute, network, everything. But you can't see it in the vSphere client or in the ESXi host client at all. So it's a ghost, right? The problem with these is, yeah, as I said, the problem with these is it's really simple to do. It's really, really simple to start a VM that's unregistered on an ESXi host if you have root access. That's how we do it. You run the VMX command, point it to a valid VMX file on a data store, and pipe all the output to null. And the VM starts, unregistered. You won't be able to see it unless you're actually actively looking for it. So a quick demo of that. This environment here, no VMs are running. It's a small lab environment. Go into the host client, have a look. None of the VMs are running, and these are just test VMs anyway. So if I SSH into my ESXi host, get a list of all the running VMs, no VMs running, run the VMX command that I just mentioned, do a new one. Oh, there we go. There's a rogue VM running. So we can see it using ESX CLI. But you have to specifically look at every VM process. And if there's a bunch of running VMs there, will you spot the one that doesn't belong? Who knows? And why would you be running ESX CLI to figure out what your VMs are running anyway? You see that in vCenter, right? So going back into the client, refreshing, Rogue 01, the VM that I created, is not listed anywhere. But it's running, it's consuming resources. So that's a one-off, right? You run that command, the VM starts. If someone restarts that ESXi host, the VM isn't running anymore. So how do you make them persistent? Well, on an ESXi host, you have this local.sh script that runs on every boot. So just add the vmx command there. That way, every time an ESXi host boots, it will run that VM. So there's one way of basically avoiding that, and that's using secure boot. If you use secure boot, which you should do on your ESXi hosts, that script doesn't run. And another way you can make this persistent is add them to a cron job, right? So every 15 minutes, just try to start the VM. If it's running, it just errors out. If it's not, it restarts it. Secure boot also stops that. The cron tab on the ESXi host doesn't run if you have secure boot enabled. So what I did, and this is kind of a repeat of what I did at Explode in Barcelona last year. I created a command and control center using the Sliver adversary emulation framework. So I have a Sliver instance in my home environment, and I had the same environment that we saw in the previous video running at my work lab. Disconnected networks, no connection between them, but they have internet access. So I placed one of these rogue VMs on each of the hosts, set up the Sliver CNC system. I had them communicate back to me from there to see what I can do with that. So same environment. I've added this to the local SH script. I reboot these 3 hosts. I'll go back to my Sliver command system and see if I can get a connection from them, right? So these are booting. And once they've rebooted, I'll go back and see. And whoops, there's host number 2, host number 3, and host number 1. Connected back to my home network via an HTTPS tunnel back into my network. And none of the VMs are shown in the vCenter or the client. These are alive. I can use them from my Sliver system, connect back to them, reverse tunnel back over HTTPS back into it, and now I'm remotely doing stuff on a VM in my lab environment without any VPN connections or anything. It's basic HTTPS. So that's where kind of this whole thing started for me. I started doing this and said, OK, this is pretty interesting. So I've expanded that into the other demos I'm going to show afterwards. But so how do you identify these? Well, if you run the vimcmd command with vmsvc get all VMs, that'll show you all registered VMs on a host. But again, it's the registered VMs because it's querying the API. If you use the ESX CLI VM process list and grep for something, I just did display in this just to narrow down the output, then you'll see the display name of Rogue 01. So the command on the left-hand side here was ran when the VM was running. The same with the thing on the right-hand side. Left-hand side doesn't show it at all. Whatever vimcmd is showing you is whatever the client, web client or vSphere client is actually showing you through the API. ESX CLI VM process list actually shows everything that's running. So that's one way of doing it. So go into your environment and run those commands and see if you can find something. There are also scripts available to do that. I haven't linked to them in this one, but you can find those pretty easily online. So how do you mitigate for these? Well, as everything else, you need to keep your stuff patched. Update and patch as quickly as possible. You never know which vulnerability patch might actually prevent someone from getting access to this, right? So keep patching, and do not enable SSH on your ESXi hosts. In a perfect world, there wouldn't be SSH ability into ESXi at all. There is no real need for it, to be honest. I hope it gets removed at some point. There's nothing you have to do. I haven't identified anything you have to do on the console of an ESXi host that you can't do through the APIs. And that should be the only way. But right now, SSH is there. If you use lockdown mode, that helps. Of course, enable SSH and disable it afterwards when you have to use it. Consider using SSH keys instead of usernames and passwords. Firewall off your ESXi management planes from clients, from anything, pretty much. And enforcing MFA, but that's kind of, it's not that easy to get a supported MFA solution directly on an ESXi host. So investigate that before you go down that route. But there is really no way to disable SSH completely. All you do is stop or start the service. So if someone gets in through the console, they can start the service anyway. Or if someone gets into your vCenter, they can just start the service, right? It's still there, even if you disable it, which is not a good thing. Monitor your logs. These things will be visible in your logs if someone enables SSH, if someone logs in through SSH. So make sure you enable that. There is also a way to, from the vCenter, create an alarm in the vCenter that notifies you if someone enables SSH as well. So that might also be a good thing to enable, right? And use secure boot. At least that solves kind of the persistence problem for these VMs. And also, if you're using distributed switches or NSX distributed port groups, it's going to be much harder to actually get an unregistered VM on the network, because that requires that the VM is registered with the vCenter for it to be able to get network access. So that's also a way of limiting the impact rogue VMs might have. OK, so next topic, exfiltrating data. This is kind of fun, in the fun sense that I mentioned earlier. Or, as I said, what scattered spiders should have done. I'm going to get some stick for this, I guess, but yeah. So you have this rogue VM, right? You have access to it. So how about attaching a VMDK from another VM in that environment to that rogue VM and reading the data? Should be possible, right? Problem is, and copy data out from it to that VM, and then exfiltrate the data. If I used my sliver system, right, I had direct connection to that VM, so I can SSH to ESXi host, do this, attach the VMDK to the machine that has access to, has connection back to my CNC, and exfiltrate data that way without anyone noticing. So what Scatter Spider does is basically they do this, they log in, they turn off a VM, and they attach the VMDK from that VM to a VM they control, and then they can copy data out. The thing is, you don't have to turn off the VM. If someone turns off a VM, a domain controller or whatever it might be, someone's probably going to notice, right? Well, they're probably not going to notice if you do it this way. So this VM is a Windows VM. I'll just quickly show that there were no snapshots there. I'm SSHing into my ESXi host. find out which VM ID that VM has, which is 44, the one that I want to copy data from. And then I create a snapshot, my evil snapshot, done through VMCMD. So now I've snapshotted that VM. The next step is basically running VMKFS tools to clone that snapshot into an independent disk. And once that's done, I have a VMDK file that is a copy of the original one that I can attach to my rogue VM and read the data from it without actually disrupting the source VM. So that's what I've done here now. I'm going to kill my rogue VM. As you see in the background, there is no, you can't see that there was a snapshot actually created either, right? So I'm killing my rogue VM. I'm going in and editing the VMX file for that VM that I control, and I'm going to add that disk as a second SCSI device. So that's the clone. Added it, everything. I know how to exit Vim. And then basically restart the VM again. Since the VM isn't registered, I can't actually hot add the disk in anyway. I need to do it in a VMK file. So once that's done, I'm going to see if I can speed this up a bit. There we go. So once I've actually attached the file, restarted my my rogue VM, I'm going to basically SSH into that. So there it is. I'm inside my rogue VM. I'm listing the file systems, and all of a sudden I can see NTFS disk on SDB3. That's an 80 gig VMDK from a Windows machine, so it's NTFS. I'm mounting that file system into NTFS_disk, and boom. I'm bypassing every NTFS file system security that might be there. I'm just reading this as a read-only file. You can find some interesting files on that, and I copy those to my home directory without the ESXi admin knowing that there was a clone, without knowing anyone connected the disk. And that's it. So if anyone actually paid attention here, these are the character names for the F Society guys in Mr. Robot in whoarewe.txt. So yeah, I could copy files from a running VM without disrupting it. That's fun. For various definitions of fun, but yeah, it's fun. So how do you mitigate against that? Well, all the same things. I'm using a rogue VM, right? So the same thing still applies. But again, it's locking down the hosts. And if you encrypt your VMs on the VMFS data store, someone who has a rogue VM in your environment wouldn't be able to attach that disk to their VM because you're not able to connect an encrypted disk to an unencrypted VM. And to be able to encrypt a VM, it has to be registered. Right? So encrypting your VMs would actually stop someone from being able to do this, to copy files from the VMDK. They can still clone it and do those things, but I wouldn't be able to access the data that easily. And the reason why I've had, in a good way behind that there is the next demo, which is encrypting VMs, but not in a good way, right? Not in a manner that you can actually control. So that's also something that's fairly easily done. You don't need to have external code copied into an ESXi host to be able to encrypt all files on a file system. You can use native tools to do that. And this is a demo that took an hour and a half, just waiting for the encryption. But yeah, So what I'm going to do here is basically shut down all running registered VMs. I don't have to do that for all VMs. If I want to encrypt just one, I can stop that one VM, but it has to be in a stopped state, not running, for this encryption to work. But the demo is doing these things. It's basically shutting down all the running VMs, well, all the running registered VMs, so I don't encrypt myself, which would be bad. And will then encrypt all writable files with native OpenSSL, with the native OpenSSL binary, which is readily available in the ESXi CLI in the terminal. And lastly, it will then erase the shell history and the shell.log file, so someone can't go back and figure out which password I used, because that's stored in the commands, right? So let's just wipe that at the same time. So this, if you copy and paste this stuff into your ESXi hosts, you're going to have a problem, right? So please don't do that. Well, if you do it, don't blame me afterwards, right? So what happens here is, the first part here basically is for loop that goes through every registered VM, gets the VM ID, the same thing I did when I identified the VM that I wanted to clone the disk from, but it just does it for everything. Finds the VM ID and then runs a new command which does a power off. I don't care if it's shut down properly or not. It's just a power off. I'm going to encrypt this thing. I don't care, right? This isn't sysadmin doing things in a proper way. This is creating disruption and encrypting stuff, right? So I'll just power them off quickly. Once that is done, I'm going through all of the files that I find from the path I'm in and down the directory tree. And I'm going to encrypt all those files with OpenSSL using an AES 256 CBC encryption model, right? I'm going to add a salt to my password, and the password is stored in the environment variable mypass. Once that's done, once it encrypts it, it takes a file and encrypts it with the .oshit extension, and then it deletes the original file. And the last part of this is wiping the history. So I did that in this environment, forgetting that I had that 90 gig VM there that I just copied. So it took a while. So this is shortened. But here it is. This is the entire command, cut and paste. I've set the password already. It's now just powering off all the VMs. And there we go. So basically, now it was done encrypting all these small files. There is a bunch of snapshot things here. That's because this is on a NetApp file system that has automatic snapshots, and I couldn't encrypt those because I don't have write access to them. So I have a way back. But the thing is, once I now try to start power on one of these again, not possible. The original VMX file isn't there anymore. There's just a vmx.oshit. And if I try to look at that file, you can see that, well, there we go. It's encrypted. So the process took quite a bit longer than this to do, since there was big disks on these VMs. And the other thing is, this is a nested lab environment that doesn't have too much CPU assigned to it. But basically, there's a one-liner bash script. You can copy and paste and encrypt all your stuff without the need for external code, which, again, makes that exec install only parameter pretty useless to defend against something like this. So how do you mitigate it against things like that? Well, again, if you're using your own encryption, that might help. You have to ensure that everything from your ESXi hosts are logged externally as well. Since I can clean my log files after me, the log files after myself on the local system, you need to have those logs shipped out. You need to have an external syslog to be sure. If you had here, you would probably, from the shell.log, see which password I used to encrypt the file, so you could probably decrypt them again. But since I'm wiping it locally, you won't find it there. And again, that log file, shell.log, is pretty important to keep track of, because it logs basically every command that's run on the host. And that was it. I think that's the first time I've had 12 minutes left for a session, ever. But that's it. Everything I've talked about here is available through that link on the QR code. The exact command you want to run, the bash scripts, everything, you can copy and paste it from there. Everything is available. And yeah, thank you, and please practice safe ESXi.